Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore how to implement parallel processing in Pandas. Okay, so many times in solving our day-to-day business problems we might need to create user-defined function and we have to apply that user-defined function on each rows in our Pandas data frame, maybe on a particular column. Okay, so that time what we do, we write our user-defined function and we use the .apply method to iterate row wise and apply the function on a particular column in our Pandas data frame. But in this process, generally .apply takes huge amount of time, because I hope you can easily understand that it is going to iterate row wise and apply the function. So it is a time consuming process, or time complexity is very high. So if we can apply that .apply method or our user defined function parallelly on different rows, that will obviously improve the time complexity for the process and overall improve our pipeline performance. So in this particular video, we are going to explore how to do the same. So without any further delay, let's directly jump into the code. So here what we are doing, first we are importing Boto3 and Pandas, because Boto3 is needed to interact in between Python and our different AWS services, and Pandas obviously we are going to use, because on that only I am going to show you the parallelism factor. Okay, so here you can see requirement already exists, and then here we are importing Boto3 and Pandas. Now here we have written a function which is going to create the input Pandas data frame for us. So what it is basically going to do, it is going to iterate in this particular input directory. It will get all the object names and it will create a Pandas data frame where first column will be the bucket name and the second column will basically contain the key or the folder structure and the file name or the object name with it. Okay, so this is a simple code. First we are creating the Boto3 client for our S3, and here we are applying pagination just to make sure that list object v2 is not missing any objects due to large number of files, and here we are appending all the contents in this key array or key list. Okay, and then again we are iterating in the key list. The first key obviously will be having the folder name itself, like here multiple small data set. So that folder I want to ignore. I am only interested in the file names or object names, and then all those information I am appending in list objects list. Okay, it is going to have two elements. Number one is the input bucket name, and the second part is going to be the key or the folder structure and the file name. Okay, and then here we are giving the column name. First column name is the input bucket and second column name is input key. We are creating the Pandas data frame out of it. So let me just create this particular function, and here I am applying that particular function. First here we are giving the input bucket name and then here input folder name. So here you can see this is our bucket and this is our folder where we want to iterate and create the Pandas data frame, and we are applying .head just to view the data. So here you can see we are having input bucket which is having constant value throughout the column, and here input key, it is basically going to have the folder structure, that is first here the folder name and then here we are going to have the object name or the file name. Okay, right? So now here what we are going to do, suppose our requirement is copying all these files from this input location to output location, and let's consider this is our output location which is in another bucket and the folder name is copy folder. So basically we have to copy all the files from here to here. So what we can do, we can basically create user defined function which is going to perform the copy operation. And before that, if you want to check the length of the data frame, here you can see 850, because here in our input directory we are having total 850 objects. Okay, and now let's see the user defined function, what it is going to perform. First it is going to take the source bucket, source key and the destination bucket and the toggle. Okay, so source bucket and source key obviously needed, because what we want to copy, those information I will be getting from these two inputs, and where I want to copy, that I am getting from this destination bucket parameter. And we have basically created another input toggle which will help us in understanding whether the copied file S3, this particular function will copy the content in this copy folder, or there is another folder called copy parallel in this folder. That is basically, this is going to help us in deciding the output location. That's it. Okay, so here what we are doing in our user defined function, first we are creating the Boto3 client for our S3 and copy source. This kind of dictionary we have to create based on the documentation of Boto3. You can easily explore this bucket name and the source key, and then here we want to copy the source file in the destination location, right? So what is the object name that we want to get? So the source key I am splitting based on slash, and then I am taking the last element out of it, which is basically going to have only the object name or the file name what we are going to copy, like these values. Okay. And then here, if toggle equal to 0, we are going to copy in the copy folder, here basically this particular location, and if the toggle is not 0, we are going to copy in the copy parallel, that is another folder. Basically I want to execute the same function just to show you the demo with respect to parallel processing and with respect to serial processing. So that's why I have created the toggle parameter, and based on that the output directory will be detected and the output file name will be same as our input file name. So here, although folder names are different, but the file name I have kept the same whatever we are having in our source file name. Okay. And then we are using s3.copy object to copy the file from one location to another location. If the copy operation is successful, we are returning file copied successfully, else we are simply returning it failed. Very simple function which is basically going to copy s3 object from one particular input location to another location. Right? Now here what we are going to do, we are going to use this particular function and apply method to perform the copy operation. So how much time this copy operation will take, to understand that, here I am basically creating start time and end time, and finally I will subtract those to get the duration of the copy operation. And here whatever this function will return, that we are going to store in copy status, another column in our same input data frame we are creating, and we are applying .apply method, and here the copy file s3 function we are going to apply on each row in our pandas data frame. Here the input should be input bucket, input key. So input bucket and input key are available in our pandas data frame already, and here we are providing what is the output bucket name, and that is Snowflake Blue Test, basically this particular bucket. Here only we have created two folders, one to show you the serial copy operation and one to show you the parallel copy operation and compare their performance. Okay, right? We are applying this particular copy file s3 function on each row, and finally we are printing the duration. So let's start this particular function and let's see how much time it is going to take. So here if I go to this particular location copy folder, because I am performing serial operation and here the toggle is 0, so that's why what will happen, it will copy the content in copy folder location, and we should see the files that coming in this directory. Here you can see already 47 file came, and if I refresh, now the object count changed to 62, and then here 71, like that. It is keep on changing. Okay, so here we have to wait some time, because already in our pandas data frame we are having 850 objects, and here this .apply is a serial operation, so it is going to copy files from each row one by one. So obviously it is going to take some time. Let's wait for that, and once the operation will complete, I will resume. Okay, so now the operation is completed and the total time taken is 297.61488 seconds. Okay, so if I go to our this particular directory, if I refresh, here we should see that 850 objects should be copied. Right? Now here it took a sufficient good amount of time, and if I apply .create operation on this data frame, now we will able to see a new column got created called copy status, where it is having file copied successfully. If we want to validate whether any copy operation failed or not, here we can simply apply a filter operation just to check whether any copy status is having value which is not equal to file copied successfully, and we can apply .head, and here you can see there is no output after applying this filter. That means for all the rows the file copy operation is successful, and here in our this particular directory from our input location the files got copied. So this particular .apply method has done its job properly. But now the point is, can we improve the performance by applying parallel processing? And the answer is yes. And how to apply parallel processing, or how to apply the .apply method on our pandas rows in parallel manner? The answer is Pandarallel. Okay, so this particular module is basically going to help us in parallel apply. Okay, so I will just do a pip install this, and here we need to import this first, and then we need to initialize. So in initialization, we are basically providing two parameters. One is progress bar true. So here progress bar true is basically going to help us in visualizing that what is the status of each parallel process and how many workers parallelly we want to run. that here we can configure using nv_1. So here we are configuring that 8 parallel processes should run. So based on that, here we are initializing and here we are getting this particular information, right? Now here again I am going to create the same pandas data frame, which is basically going to contain all the object names, and the first column is basically going to be the input bucket name, like here df1.head if I apply. So here the same thing is there. Now here we will apply this particular module to use .apply method in parallel manner. And how to do that? It is very simple. Just instead of .apply, we have to use parallel_apply. Okay. So same like earlier, here also we want to check what is the total time taken. So we are configuring start time and end time. And here copy status, we are creating a new column, and .parallel_apply we are applying on our input data frame. And here input bucket and input key we are passing as the input for this particular function. The function is common in between this case and our earlier case. Only thing is here toggle we have kept 1. So because toggle we have kept 1, so what will happen? It will copy in copy parallel folder instead of copy folder. That is basically in this particular location the files will be copied, right? That's the only different thing. So here now I can run this particular function, and here you will see because we have configured number of workers as 8. So here total 1, 2, 3, 4, 5, 6, 7, 8 processes started. And because here we have written progress per true, so that's why it is beautifully showing that in each parallel process what is the progress. So here you can see the percentage and actually the distribution that this particular process got 107 rows, out of that this many rows processing is completed. Like that manner for each process, what is the total number of rows it got and for how many rows it has processed, that it is showing in the progress part. So from this particular visualization itself, I hope you can clearly understand that .parallel_apply is going to use our user defined function parallelly on the different rows. Okay, and obviously as a result the time complexity will be improved. Ideally it should take lesser time because parallel processing is happening. We'll compare the total time taken once the process is completed. So here it's almost done, and once each process will complete, the color will change to green color, and here all the processes are completed. The total time taken is only 78 seconds. Earlier it has taken, if you see here, 297.61 seconds, but now using .parallel_apply method it is taking only 78 seconds. And here in this particular location we should see 850 objects should be copied. So the object count is same, that means there is no such row for which we got error. That also I can show you here. Now if I do df1.head, here new column got created with copy status, and if I apply a function just to check whether there is such row for which copy status is not taking the value file copied successfully, here you will see no row is coming. That means for all of the rows file copied successfully, right? So using this particular parallel_apply method, we can basically use the concurrency or parallel processing power of pandas. Okay, so this particular concept may help you to improve any existing data pipeline or in building the new data pipeline. So I just thought to share this particular concept with you. And if you think with respect to Gen AI how we can implement this, let me show you one example of the same. So here I was going through this particular AWS sample where they have basically explained how to build AI powered semantic product catalog search. Here they have implemented .parallel_apply. So here I can show you, and why they are using that also I'll explain. So here if you see in this particular process they have applied. So in our case, why we have used .parallel_apply? Basically to copy files from one S3 to another S3. And here in this particular code, we can use .parallel_apply to perform embedding parallelly. Okay. So whenever we build any RAG application, that time as a first step, we have some sort of input text or input PDF files. We need to convert those text or PDF files or images to its vector representation, right? Now suppose we have text in pandas rows, and you want to get its vector representation to store in PineConeDB so that later in some point of time that same data can be used for RAG application. So now converting individual text in a pandas data frame row to vector form, we need to apply embedding, and one particular row embedding is independent with respect to another row embedding. So the embedding for different rows we can perform parallelly. So that's why they have used dot parallel apply to generate the embedding. So this way dot parallel apply is a very important and useful method, especially when you are working in GenAI world. And I hope you understood the use case. Not only in generating the embedding for our RAG application it will be useful, you can think about it, and I'm pretty sure that you will get lot more use cases about it. And if you consider the security part, here you can check the modules vulnerabilities in this Snyk. Here currently there is zero critical or high vulnerability available. So this particular module is safe to use also, right? So I hope this particular video will help you to build data pipeline which will take lesser time if you are using dot apply method in your Pandas data frame. This is all for this video. The complete code I'll be providing in the description box or in the comment section. Just go through it, try to run it, try to experiment with it, go through the documentation of this particular module so that you will get more better idea out of it. And if you have any doubt, don't hesitate to ask in the comment section. I will try to reply back ASAP. So this is all for this video. If you find this video helpful, then please like, share and comment, subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.